Hello, I'm Mike McCulloch. Today I'd like to tell you about the day I deflected a hurricane. And I should say straight away that it wasn't a real one, it was a model one, but it was exciting nonetheless. So back in the days that I worked at the Met Office, the UK Met Office, this was towards the end of my stint there, 2008, I'd read some things about, I've been doing some wave modelling and some modelling of the sea surface temperature as well, and I was interested in the interaction between extreme atmospheric events like hurricanes and the sea surface. Could they interact? And so I proposed to my line manager at the time that I model it using a coupled air to sea model. So I was allowed to do it, and I got some advice on how to do the modelling, because it was quite intensive, and I managed to couple the ocean model we had, which was called FOAM, Forecasting Ocean Assimilation Model, with the NWP model of the Met Office. So that's a numerical weather prediction model at the time. I managed to couple them so the atmosphere was aware of the sea surface temperature underneath it, which has an effect because it influences air buoyancy and that sort of thing, and vertical transfer of momentum. And the ocean was also aware of the atmosphere, so the heat coming in from the sun and from conduction, that sort of thing. So the two were linked. And I modelled several hurricanes. And I modelled 4 hurricanes that had occurred in 2005, one of which, Rita, was very interesting, and I'll come to that in a minute. Another one, Katrina, was also quite disastrous for New Orleans. And what I did was, in order to determine how the ocean surface affects hurricanes, I modelled it with 2 sea surface temperatures. So the first was a kind of basic sea surface temperature map of the Gulf of Mexico that I got from the files, and I put that into the model and ran it starting from that. And the hurricanes had a particular trajectory, which was almost but not quite the same as the observed one. And then I used a far higher resolution sea surface temperature map, which we called Ostia at the time in the Met Office. And the interesting thing was that the trajectories were not the same. There was a difference. And it turned out that for one of the hurricanes, the difference was quite large. This was Hurricane Rita from 2005. And I happened to notice there was an eddy, a warm vortex of water in the Gulf of Mexico at that time, just to the right of Rita. So I thought, what would happen if I deleted that eddy? So I deleted it, ran it again with just an average sea surface temperature where the warm eddy had been, and the hurricane diverted its path by about 70 kilometers. And it's quite a lot, actually. So this was very interesting. So it means that if you had a real hurricane, or it could mean that if you had a real hurricane and you were somehow able to cool down a region of the ocean the size of perhaps Belgium, an eddy, a warm eddy, by a certain amount, then maybe you could deflect it, and maybe you could control the trajectory of hurricanes. So I wrote a paper on this. Well, it was actually a conference paper, a very short paper, with 2 colleagues, and published it in a conference, and went to Orlando to present it in Florida, because they're quite interested in hurricanes down there for obvious reasons. And yeah, so that was the last thing I did before I left the Met Office, and it was a very interesting thing to do. Okay, so I hope you've enjoyed this short, and I look forward to seeing you tomorrow. Goodbye.